Hey, I've got some math for you here. This is Braess's paradox. The question is, can adding a road make traffic worse? Well, let's see if it makes sense. So here we have our starting city, and here we have our ending point. So all of our drivers start over here, and they're trying to get over here. Now this road always takes 7 minutes to travel down. You see it's nice and wide, so there's no traffic slowdown, no matter how many people are on it from this city. And maybe it has a lot of red lights across it, so it always ends up taking a while to get down, 7 minutes. This road is also nice and wide, but maybe it doesn't have any red lights across it, so it only takes 1 minute. However, these two roads are kind of narrow, so they're susceptible to traffic slowdown. If we had 100% of drivers on this road, then x1 would be 1 for 100%. So it would take 4 plus 1, 5 minutes to get down the road. Now, if it was 0% of drivers on the road, then x1 would be 0, and it would only take 1 minute to get down the road. And if we had 50% of drivers on this road, then x1 would be 0.5, and it would take 2 plus 1, 3 minutes to get down the road. So the question is, what's going to happen? Well, we're going to assume that each driver takes the best path that they can. They want to get to the other side as quickly as possible. So what's going to end up happening is, if this road right here is blocked off, then 50% of drivers are going to take this path, and 50% of drivers are going to take this path. Well, think about it. If it was 60% here and 40% here, then the traffic on this road would be a little bit worse than the traffic on this road, meaning that some of the drivers taking this path would decide to change their path to this one because it would be quicker, and they would keep doing that until we got that 50% equilibrium. So here I have illustrated the picture. It's going to take 3 minutes plus 7 minutes for half of the drivers, and 7 minutes plus 3 minutes for half of the drivers. 10 minutes for everyone with this road blocked. Now what's going to happen when we open that road up? Now we have an extra road. Well, it's 10 minutes here, it's 10 minutes here, but look at this path here, this zigzag path. It's 3 plus 1 plus 3, so this is 7 minutes if people take this path. So that is a better path. So some of the drivers that are going this way are going to switch to this, and some of the drivers that are doing this are going to switch instead to this. Everyone is going to use this new wonderful path that improves on their travel time. So let's say that everyone starts using this path. Well, now the traffic here gets really bad again, and the traffic here gets really bad. So how is everyone doing now? Well, let's see. It's 5 plus 1 plus 5 for 11 minutes. So everyone is getting an 11-minute path. Well, everyone used to be getting a 10-minute path. So things actually got worse. So you might say, well, I'll just go back to the old way. I'll just take this path. That was the better path, right? Well, not anymore, because now 100% of people are using this road, and 100% of people are using this road. It used to be 50%, 50%. So now if you take this path, it's 5 plus 7, which is 12 minutes, which is even worse than the 11 minutes. So no one wants to do this, no one wants to do this, everyone wants to do this, and it's making everyone worse for it. Essentially, the drivers are competing with each other more intensely now and making each other worse off. But that is still on an individual by individual basis, the best choice. So if you were to try to be nice maybe, and you said, okay, I'm going to use this path instead, you would make traffic over here better for lots and lots of people. You would actually save everyone. Like if 1% of drivers started taking this path and then it was 99% doing this path, the average travel time would actually improve, but that 1% of drivers would have a worse travel time. So yeah, if you want to be nice to everyone else, you could disadvantage yourself to do so, but we're going to assume that all of the drivers minimize their travel time. So if they all minimize their travel time, they're not going to be altruistic, so to speak, right? And then you're going to end up with everyone a little bit worse off. So does this actually happen in real life? The answer is yes. Not just in traffic, but in many different kinds of physical systems. It's a very interesting way in which everyone doing what's best for them can end up making things worse off overall for everyone than what was possible if there was cooperation from the beginning. If you have any questions, let me know. Take care.